Hey guys, today we are going to talk more about radical equations, and for this opener I'm actually going to split it, and we're going to do number 2 here at the beginning, and then we're going to do this rational equation at the end for a little bit of review. Okay, so here on number 2, I've got 2 radicals on the left side, and it's going to be a lot nicer if I just have one radical per side. So I'll take the one that's negative and move it to the other side to make it positive. So I get the square root of 3m plus 4 equals 3 plus the square root of 2m minus 7. Okay, so now that I've got one radical per side, I can square both sides. On the left, the radical and the squared cancel. So I get 3m plus 4. On the right, I have 2 separate terms, so I'm going to follow this pattern. A plus b squared equals a squared plus 2ab plus b squared. So that's the first term squared plus double the product of the 2 terms plus the second term squared. So a squared, that's 3 squared, 9. Okay, then double the product of the 2 terms. 3 times the radical doubled is 6 times the radical. And then this second term squared just cancels the radical, so I get plus 2m minus 7. Now our next step should be to get this radical term by itself, so we'll move everything else to the left. So we have 3m minus 2m, and that's m. We have 4 minus 9, which is negative 5, plus 7, which is 2. And on this side, we're just left with 6 times the radical. Okay, now I can square both sides again to get rid of that radical. Okay, so here I have 2 terms. So I'll do this pattern again. First term squared plus double the product. The product is 2m, doubled is 4m, plus the second term squared, which is 4. On the right side, I have a single term because there's not a plus or minus here between. It's 6 times the radical. That is one single term. So I can just square everything. So I get 36 times 2m minus 7. Now let's distribute. So we have m squared plus 4m plus 4 equals, okay, then 36 times 2m is 72m. And 36 times negative 7 is negative 252, so that's minus 252. Okay, now let's set that equal to 0. So everything to the left side, m squared, and then 4 minus 72 is negative 68, so minus 68m. And then 4 plus 252 is plus 256 equals 0. So now we have 3 choices. We could factor, complete the square, or use the quadratic formula. Let's try this one with completing the square. So I'm actually going to move this back to the other side. M squared minus 68m, and room for a new c, equals negative 256, and room for the new c. Okay, so to get that new c, we do half of b, so that's negative 68 over 2, and square it. Okay, so that's negative 34 squared. Okay, so negative 34 squared is 1,156. So we are adding 1156 to both sides. Okay, now I need 2 numbers that multiply to 1156 and add to negative 68, and I already have the numbers on my paper. It's negative 34 and negative 34. Negative 34 times itself is positive 1156. Negative 34 plus negative 34 is negative 68. So the factored form is m minus 34 times m minus 34, which is m minus 34 squared. Okay, so the easy way to factor once we've made a square trinomial is just to use b divided by 2 right here. Okay, so then we have negative 256 plus 1156, and that is 900. Okay, next up, take the square root of both sides to cancel that squared, and we get m minus 34 equals plus or minus the square root of 900. Okay, and then we're going to simplify that radical and move this minus 34 over. We're going to squeeze it in right there. So we have m equals positive 34 plus or minus, and the square root of 900 is 30. Okay, so we have 34 plus or minus 30. So 34 plus 30 is 64, and 34 minus 30 is 4. Okay, now before we put a box around those, we need to check. Okay, so we have the square root of 3 times 64 plus 4 minus the square root of 2 times 64 minus 7, and that should equal 3, and it does. So 64 is a valid solution. Now we'll check 4, and if 4 is not a valid solution, it's called an extraneous solution, and we'll throw it out. Okay, so we have the square root of 3 times 4 plus 4 minus the square root of 2 times 4 minus 7, and it equals 3. So both of these check out, so I get to keep both of those two solutions. So now let's solve some more radical equations together. So my first equation, I have a radical on both sides, so I want to square both sides. On the left side, the radical and the squared cancel, so I get x plus 2. On the right side, the radical and squared cancel, so I get 3x minus 2. Okay, so let's move this x to the right side, and move this negative 2 to the left side. So I'll have 2 plus 2, which is 4, and 3x minus x is 2x, and divide by 2, and we get x equals 2. Okay, now before we can settle on that as a solution, we need to check it. So 2 plus 2 square root equals 3 times 2 minus 2 square root. So that's the square root of 4, which is 2. And this is 3 times 2, 6, minus 2 is 4. And the square root of 4 is 2. Our solution checks out. So x equals 2. Okay, so here we have one radical per side, so we're going to square both sides again. X plus 2 under a radical squared, the square root and the squared cancel. X plus 2. On the right side, though, I have a plus here, so I've got two terms. So I need to do a squared plus 2ab plus b squared. So a squared, 4 squared is 16. 2ab, multiply these and double it. 4 times the radical, doubled, is 8 times the radical. And then square this second term and you get x minus 6. Okay, now let's get the radical term by itself. So we have x and then minus x, so those actually cancel. Okay, then we have 2 minus 16, so that's negative 14, plus 6 is negative 8, equals 8 times the square root of x minus 6. Okay, I can divide both sides by 8 to make this a little bit simpler, and I get negative 1 equals the square root of x minus 6. Now at this point, I already know that the answer is no solution. Okay, there's no real solution to this, and it's because a radical, a square root, cannot equal a negative number. Okay, so I can say no solution and be done. However, you might not recognize that sometimes. You might just want to keep on going. So let's just keep on going and pretend we hadn't noticed that yet. So we're going to square both sides. So we get 1 equals x minus 6. And we move that minus 6 over and we get 7 equals x. Okay, so that's our solution. But we have to check it. So we get 7 plus 2 square root equals 4 plus the square root of 7 minus 6. Okay, so we have 7 plus 2, that's 9. The square root is 3. Okay, then we have 4 plus 7 minus 6 is 1, and the square root is 1. And we get 3 equals 4 plus 1. 3 equals 5. That is not true, which means this right here is an extraneous solution. So there's no solution here. Okay, the only solution we got, we have to throw out. And our last one here, we do not have one radical per side, so we need to make it one radical per side. So we'll move the negative one to the other side. Okay, and then we will square both sides. So on the left, square root and squared cancel. 3x plus 1 equals. On the right, we have two terms. So a squared is 1 squared. 2ab, double the product. I have 1 times the radical, double that, and I have 2 times the radical. And then b squared is x plus 4. Okay, so we'll get the radical term by itself. So I have 3x minus x, that's 2x. These 1's will cancel, but then I have a minus 4. So 2x minus 4 equals 2 times the square root of x plus 4. Let's make everything a little simpler by dividing by 2. So x minus 2 equals the square root of x plus 4. And let's square both sides. First term squared is x squared. The product of these is negative 2x, double that, and I have negative 4x, and negative 2 squared is 4. Okay, on the right side, these cancel. Okay, so let's move everything to the left, and these 4's are going to cancel. So we'll have x squared minus 5x equals 0. I can factor an x out of both terms. X times x minus 5 equals 0. And there I can get my two solutions. X equals 0 from this factor, and x equals 5 from this factor. Those are the two factors that would make this equal 0, the two roots that would make these equal 0. Okay, so now let's check our solutions. 3 times 0 plus 1 square root minus the square root of 0 plus 4 should equal 1. Okay, so that's 3 plus 1 is 4, and the square root is 2. And 0 plus 4 is 4. Square root of 4 is 2, so I get 2 minus 2 equals 1. And that is not true. And you know what? I made a mistake here. I said 3 times 0 plus 1 is 4, but it's not. 3 times 0 is 0, plus 1 is 1, and the square root of 1 is 1. So I have 1 minus 2, but that still does not equal negative 1. So I have to throw out my solution of x equals 0. Okay, now let's try the 5. 3 times 5 plus 1 minus 5 plus 4 equals 1. Okay, so that's 15 plus 1 is 16, and the square root of 16 is 4. 5 plus 4 is 9, square root is 3. 4 minus 3 equals 1, that checks out. So x equals 5 is my final solution. To number 1 on this opener, we have a rational equation here, and we want to multiply the entire thing by all the factors of the denominators. Okay, so I see a factor of a denominator here, that's x. This denominator is x plus 2. Now, this denominator is x squared plus 2x, but out of this denominator, I can factor an x. So this x squared plus 2x is the same as x times x plus 2. Which means its factors are x and x plus 2, and I'm already multiplying by those factors, so I don't need to multiply by those factors again. So when I distribute here, x plus 2 cancels, so I'm just doing 3 times x. When I distribute here, x cancels, x plus 2 cancels, so I have nothing left to multiply by, so it's just plus 6. And then when I distribute here, x cancels, so I have 3 minus x times x plus 2. Okay, so I'm going to have to distribute this one. So I have 3x plus 6 equals 3 times x is 3x. 3 times 2 is 6. Negative x times x is negative x squared. And negative x times 2 is minus 2x. Okay, now let's put everything on one side and set it equal to 0. And I'm going to choose the left side because the x squared term is negative. So I want to move everything to the left so that the x squared term becomes positive. So I'll have a positive x squared. Okay, then I have a 3x and a 3x. Those actually cancel. I have a 6 and a 6. Those cancel. Negative 2x moves over and becomes positive 2x. Okay, so I can factor this and get x times x plus 2. So I'm just dividing both terms by x. If I distribute that back, I get x squared plus 2x. So I just factored out the greatest common factor. Okay, so that gives me two solutions. X equals 0, because that would give me a 0 factor here, times this will be 0. Okay, and then I can put a negative 2 here. Negative 2 plus 2 is 0, so I would get negative 2 times 0 is 0. So those are my two solutions. Now, before I accept my two solutions, let's go back and check the domain. What value of x would give me undefined terms? Okay, so if I would have a 0 denominator, here negative 2 plus 2 would give me 0, so x cannot be negative 2. Here, a 0 would give me a 0 denominator. X cannot be 0. And here, a 0 and a negative 2 would give me a 0 denominator. So the things that would make 0 denominators are negative 2 and 0. Okay, so I cannot have those as my solutions because they would give me undefined terms. And both of my two answers here violate the domain. X cannot be 0, x cannot be negative 2. So both of the solutions have to be thrown out, which means there is no solution.